Hi, welcome back everyone. I'm Dr. Joseph Francis Wong. I'm the Vice Principal of the Hong Kong Design Institute, HKDI, and I will be your moderator for the afternoon session. If you're only joining us this afternoon, before we begin, a few housekeeping matters for your online audience to note. At the bottom of the screen, there is a Q&A button. You're welcome to submit questions to our speakers and moderator, which is myself, at any time during the event. Okay, let's start. The first speaker for this afternoon is Dr. Zhanpeng HUANG from SenseTime. Dr. Huang is now a Senior Vice Director at SenseTime and takes charge of developing 3D and augmented reality-related products on mobile devices. He is interested in combining computer graphics, computer vision, and deep learning technologies to develop products with novel user experience. Let's welcome Dr. Huang.
Excited to be invited to attend this forum. Today, I'd like to give some viewpoints from the technical perspective of 3D industry. My presentation includes 3 parts. In the first part, I'll give a very brief introduction of artificial intelligence, and we'll also discuss some problems that we may have about the design in 3D industry. And then we'd like to give, in the second part, I'd like to give a very brief overview of the potential technologies that may help us to design in 3D industry. In the last part, I will show some cases that we have leveraged the artificial intelligence to help us in design in SenseTime. Okay, let's start. So what's the problem of design in 3D industry? Before diving into this problem, let's give a very brief understanding of artificial intelligence. So when we talk about artificial intelligence, we'll not get the common viewpoint. Some will think that it's a threat, just like what has been happened in some science fiction movies, such as the Terminators or the Matrix, where the AI-empowered machines or robots just try to govern or even kill people. While some other science fiction movie fans, they believe that in future the AI can empower humans' capability so that we can do very cool things or have the ability that we have not enabled right now, just like the Iron Man. So no matter it will kill us or will empower us, it seems still very far away. But as more and more information or articles or newspapers say the AI will take our jobs or will be replaced by AI or we have to compete with AI for a job. And some articles even give a list of top 10 jobs that AI perhaps will replace us. With so much information like this, I think we will get more and more upset and ask one question for ourselves: will we really be replaced by the artificial intelligence? The answer is of course the answer is not very definitely. But before to discuss this, let's give a very brief overview of the history of artificial intelligence. So what is artificial intelligence? In fact, it's not a new technology. It can be traced back to 1950s. And the definition is also very general. So any techniques that enable computers to mimic human behaviors. So maybe we will have no idea about this. In fact, since the last 60 years, the artificial intelligence has gone through ups and downs for several times, and each time when it rises up again, it will be renamed a new names. For example, in 1990s, in second rising up, it has a new name of machine learning, and in 2010s, It has a very cool name. It has a very cool title named Deep Learning. So deep learning, even even for us, I think this is very cool names, and you may see that in fact artificial intelligence have a very wide scope than the deep learning. But since the deep learning is so popular, and I think any of us may have already heard about some about deep learning. So in this report, I will interchangeably use artificial intelligence and deep learning, although they may not exactly the same. So why deep learning get popular? There are majorly three reasons. The first one is that indeed some new algorithms have been developed, just like the deep learning technologies. And I think there are the two very important factors. One is that there are massive data that we can access through the internet, and also there are a great improvement in the powerful computing resources. With these three factors, the deep learnings developed fast and even faster. So what's the fact in artificial intelligence? Since it started rising up in 2010s, artificial intelligence indeed succeed in many fields, especially in the field of video processing and audio processing, and it also have been successful in some applications such as self-driving, self-driving, and also the audio assistant systems. It seems that artificial has already happens in our daily life, but it's far from saying that artificial is perfect. In fact, just a few weeks ago, it reported a mistake by the artificial intelligence. It said that broadcast service providers uh, use AI systems to control the cameras so that the audience can always capture the football spot. But when they use it in a live football match, and the camera, the oh sorry, and the camera and the AI-powered systems always try to track a lineman, so they found why, and then they discovered why, and then they found that because the the lineman has a bald head, and the artificial intelligence systems just confuse the bald head as football. And also the artificial intelligence, especially the deep learning technologies, are also abused, are also criticized by many researchers that is very fragile. For instance, in fact, artificial intelligence is really good at image classifications. It has reported that it has reported that the deep learning technology has already surpassed human in image classification. But when we try to add some random noise to the original image, the artificial intelligence will recognize it as other categories. So just give these two cases. The two cases is so simple that we human can do it right. But even for this simple case, it may be still very difficult for the artificial intelligence. So we already know that artificial intelligence is not a very new technology, and also we know that it's not perfect, and I think the most fortunate thing is that I think most of us are not in the top 10 list, so we may can take a breath and relax. But the still one thing that we have just mentioned. So what's the problem of 3D of the problem of design in 3D industry? Just as we mentioned, I think one of the most challenging is the cost. 3D assets or 3D models really are really expensive. So a single 3D model with moderate complexity will cost up to 5,000 US dollars. So a virtual scenes or a virtual world just with similar complexity will cost up to 20,000 US dollars. So why is it so expensive? I think the one reason is that 3D modeling is really time consuming and also requires very professional skills. And also it usually takes a professional 3D modelers to 2 or 3 turnarounds to get the final results. It said it may take about 60 hours for professional 3D models to finish the 3D model. So that's really expensive. I think another reason may lies in the fact that in a team there are technicians and also some non-technicians. It will be very difficult for them to discuss in the same context. For example, the technicians such as software developers that usually just focusing on how to implement details, while the non-technicians such as product designers or product managers, they just emphasize on high-level product functions and user experience, which are more abstract, and it's very difficult for them to communicate. So if they have any, how to say this, there any schemes or any common language that they can communicate with each other in the same context, I think this will make the communication much more efficient. And another problem I think in fact is related to the second one is that especially for the software development industry, just as the 3D games or augmented reality industries, that most of our systems are software based, and software development is so fast, and you have to iterate it again and again. So the product managers or designers always have to try to think some new ideas or new functions in order to make your system more compatible, more compatible. But even for single ideas, it will require a lot of workload for software developers to develop it. So if there are any way to fast verify the ideas and also the modifications, it will be great help in design. So let's take a look at how the AI technology can help us in design. And one technology called GAN, or the generative adversary networks, can really help us. So just as the image shows, you do not need to draw every details of the design. You just need to assign each different part of the creatures, and then the GAN technologies will create much detailed textures and colors for you. And what's more, it can even generate different poses and different illuminations and even the background for you. So with this technology, you do not need to focus on details. You only need to get the whole pictures, and the algorithm will try to generate it for you. I think this will accelerate the design process. For For other designs, such as cartoon, in Japanese, such as cartoon, such as cartoon that requires a lot of detailed, detailed, detailed curves, it may be difficult for them to generate it directly. But the AI technology can also help by colorizing the sketches or even light up sketches. For instance, given the finished sketches, and the algorithm can try to colorize the sketches and even give some emulation effects. And this, in fact, this task is very complicated because all these images are in 2D, all these contents are in 2D fact, and the lighting in fact is related to 3D structure or geometry structures. And but the AI technology can estimate it automatically and give you the final result. And the AI technology can even help to tonify real features of a real man, of can tonify pictures of real persons, just as the image shows that it may generate some styles, perhaps the Disney styles or Pixar styles. And what's the magic thing is that it can also even to make the figures looks much younger, and also even to feminize it. I'm not sure what this feminized style. Perhaps the movie star Angelina Jolie. And also the algorithm also provides some parameters that you can try to control how much or how much degrees that the real person to be tonified. For instance, in this matrix from left to right, from left to right, the parameter controls how less like the human is, and then from bottom to up, it will try to smooth as much as possible details and to make it looks more like a cartoon. The mentioned works so far always are related to how to help you design with AI technology, but there are some AI technologies that help us in other ways. In this work, just given a sketch, and the AI technology will try to estimate the drawing orders of the sketches. For instance, just as the image shows, each number shows that the drawing orders. So what this can help, especially I think especially for the beginners, we were always confused how to start the first drawing and then the second. But with these technologies, it can automatically recover the drawing orders from a single image, and this can be used as a reference for the beginners to quickly learn how to draw. And I think the drawing orders, although I'm not a professional, professional drawer, professional artist, and I'm not very sure the drawing orders, but I think it's still reasonable. All mentioned works so far are just focused on 2D space or image space, but in fact, there are several AI technologies can also help us for the 3D model designs. For instance, just as mentioned in the first part, 3D models are so expensive because you have to spend a lot of time on the design, the generation of 3D models. But using these technologies, you just need to give a very general 2D sketches, and the algorithm will automatically generate 3D mesh. Although the 3D mesh may seems seems not have much detailed geometry structures, but it can give the general templates or growth or cause 3D models, and then you can further refine it. I think this will also reduce some sort of workload. And also, there are some AI technologies that can generate the 3D models just from the single image. I think this is really even good, even good. For instance, from in the left image, just given a single image of furniture, and it will automatically generate the very very reasonable 3D geometries. While for other images and objects or creatures that do not have very clear boundaries, it only can generate relative close 3D models. Perhaps some of you have already noticed that the generated 3D models do not have very good appearance. That's because they skipped the materials extraction. By using these technologies, just given a single image, and the AI technology will try to extract different components of the materials, such as the normal mapping or normal distribution, and the albedos and also speculars. When we get these different components of the materials, and we can then synthesize the final result. Just as the image showed, the first row is the real image, and the second row is the synthesized by using the extract components. I think even for the professional designers, it will be very hard for them to distinguish the difference of the real image and the synthesized image. That means that the AI can extract very accurate materials. So when you get the material of the object, you can render it back and also add it to the reconstructed 3D models, just as mentioned. In addition, you can also transfer the extract material to other objects, just like this image shows. You can see that the speculars and all the smoothness look so realistic. In animation products, one of the major processes is rigging. So in general speaking, rigging is a process that you insert a predefined skeleton into the 3D mesh, and also assigns the influence weight to each pixel, to each vertex of the meshes. So just listen. So you can imagine that this will be very time consuming. By using the AI technology called RigNet, the algorithms will automatically generate the reasonable skeleton, and also try to assign the reasonable weight for you. So that you just need to provide the animation data template, and all other work can be given to the AI, and they will generate it automatically to you. With this technology, it will greatly reduce the workload of 3D model and 3D animation. So let's go into the third part. I will show some cases that we have done in SenseTime by using AI technologies to help our design. And the first one is is related to face reconstructions. We use the face tracking and the face reconstruction AI technologies. By just giving a sequence of videos, we can generate 3D mesh of the face. And one advantage of our method is that we do not just create the 3D mesh of the face. We can also contain the semantic information. What does that mean? It means that we not only have the 3D mesh, but we also know that which part of the mesh is nose, which part is mouth. With this information, we can add some movement to each different part and to synthesize different various types of expressions. I think and this technology can be used for avatars in online social networks, or you can even use this synthesized expression as 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 stickers in IM in instant messaging apps. And also, as we already have the 3D mesh, we can use the 3D printing technology to print it out and use it as elements. I think this may be a good idea that when your girlfriend or your wife, you have, well, I think this is a good idea that you can print out your girlfriend's or a wife's a wife's a wife's head and perhaps also the body, and then use it as ornament, and then use it as a gift for your wife's or girlfriend's gift. We also use face tracking technologies to extract the person's expressions, and we then use the AI to transfer these expressions to virtual avatars. Just for example, in the first videos, this is the Chinese Sanxingdui browser head with golden mask, and we created this virtual avatars, and then we animate it with expression extracted from a real person. And you may notice that this avatar includes three different types of golden mask. For example, this is a broken mask, and and there's no mask, and also there is also a complete mask. So how does it change it? In fact, we also try to track the user's head, so that when the user have fast rotations, and the avatar will automatically change its mask. Perhaps you can see it much more clearly in these videos. When the user tries to rotate his head fastly, and the virtual avatar will switch around. And we can also try to animate any other. In fact, you can use to animate any virtual avatar as long as you can imagine it. And this is the self-portrait of Van Gogh. In addition to the face reconstruction and animation, we also use AI technology to reconstruct the 3D body of a real person. Just given a single image, we can use AI technology to reconstruct the 3D mesh of the body. So the difference between the body reconstruction and the face reconstruction is that although our body reconstruction also includes the face, but it is much more focused on the body details, but not the face details. When we have the 3D meshes, we can use it to animate, just like this. I think this is also very important. this is useful for 3D gaze, especially you can use the personalized virtual characters in 3D gaze or in just as some social games such as the second knife. And not only to reconstruct 3D mesh of the body, we can also extract the body's more information, such as where is the body located in the image, and also we'll track the body's skeletons, as the skeleton indicates the joint locations, so it also includes the body motions. So when you have the body motions information, we can transfer the body motions to other virtual characters, just like this video shows. And also we can try to design some virtual garment or virtual stickers and use it as a virtual try on. I think this technology can be very useful to synthesize short videos or to some interactive applications. In addition to we already have technology to reconstruct and tracking face and also body. In fact, we also have some AI technologies to track the human hands in the similar ways. In these videos, it shows that we can locate it and also extract the body, extract the hand skeletons. In addition, it also can recognize different gesture of the hand. For example, this rock style, or this fist or other or one or two fingers styles. With these technologies, we have explored its usage in some AR games. For instance, in this demo, it shows that we can use the hand to get a virtual ball and then to throw the ball with your hand. And you can also use the gesture. This is the pistol. I think this is the pistol. Okay. I think this is the pistol gesture, and you can use this gesture to shoot the virtual characters. And in this demo, it shows how can you use hand to interact with virtual characters, and the virtual characters stand on your hand, and you can also to throw it away. I think with these technologies, it will create much creative and lower user interactions for AR in applications. Okay. Apart from the face, body, and hand reconstruction, the tracking, we also focus on the single object and the scenes reconstruction. For instance, in this scene, a user just need to move around a real object, and our AI algorithms will try to reconstruct 3D mesh of the object. So when you have the objects, we can use the auto rig. So you can use the rig algorithm, just as I mentioned before, to animate it. I think this is important because as it can help non-professional users to generate their own 3D assets, and then I think as more and more users use these technologies, we can have massive 3D assets, and then with these 3D assets, we can do we can develop a lot of 3D applications. In another in another prototypes, our AI algorithms also reconstruct the 3D sense in a progressive way. So what does it can be? So what it can be used? It can be integrated into AR applications. The generated 3D, the reconstructed 3D mesh can be used as underlying geometry proxies, and then it will be used to interact with virtual objects. For instance, in this image, in this video, it shows that the virtual balls it rebound against the real these 3D geometries to create a very reasonable behaviors, just as we usually experience in physical world.
Thank you, Dr. Wang. So to catch up on time, we'll move Dr. Huang's Q&A session to the panel discussion.